Okay, starting 2.1. 2.1. But more importantly, this is the idea. There is no bigger idea in first semester calculus than the derivative. Okay, this is what changed the world. Okay, and I think I've talked about this at the very beginning in my very first video. The derivative is considered one of the greatest human discoveries of all time. Like I said, when I was a kid, you can hear Houston Control when they launched the first rocket saying it's all in Newton's hands now. Was he right about all this? And it turns out it seems to be that he is. Now, here's the thing. I'm going to kind of give you the idea, and then I'm going to kind of work backwards, like why did Newton come up with this and all that. So how it was discovered and how I'm going to teach it are almost like in reverse, but that's very common, right? Let's start with what you need to know, like what is the derivative, right? And then what we'll do is after we figure out what the derivative is, we'll kind of work backwards and go, well, why is that important, okay? The thing you always want to keep in your head, like this has to be in your head all the time throughout this whole experience, is the derivative is basically the slope. Okay, this derivative and the slope, like they're almost equal. Like you have to think of like they're not synonymous because because if they were equal, then we wouldn't need the derivative, right? The derivative is super important, okay? But having said that it's super duper important, you always want to kind of keep in mind that it's really a slope. Now, when we get to the end, I'm going to kind of clarify all that. So here's the idea. So, and again, I'm going to start using some notation that's going to look a little weird, so don't panic. We have 2 points, okay? We got a point here, and we got a point here, and then we got some function. Now, I made it really concave because it helps illustrate the idea, okay? It can be any function, though, okay? So, just for the sake of discussion, we'll call this f of x. So I've got 1 point on the function here, and now here's the thing. We're going to give it a couple different names. The name we normally use and the name that we sometimes use, okay? We're going to call this x1, or we're going to call it x, just depending on the way we're going to do the question later. Okay, so you got to try to, okay, let's call that x. And then this point here, we'll call x2. Because we normally call this point what? x1, y1, right? We normally call that, well, yeah, let's call, yeah, x and y1, that's good, we'll do that. That's groovy, we can handle that. x1, x2, y2. Now, that's not the normal way of doing that, though, okay? Okay, define normal. That's the normal way until today, right? But in calculus, we don't do that. We're going to call this something kind of weird. We're going to call it x plus h. What we're going to do is we're going to call this distance between the 2 points h. So what we're going to say then is it's x to this point, and then we're going to add h. So what we're going to do is we're going to think of this as x, and we're going to think of this x plus h instead. So we're going to think of them in a couple different ways, okay? And it's important that you understand that we're going to think of it in a couple of different ways, okay? It'll become imperative that we can think of it. And here's the weird part. The x plus h way is more important. You might remember that because we had some limit questions earlier that I pointed out were calculus questions and they had h's in them, right, with h going to 0. So then over here, like I said, we call this y1, or we can call it y2. But what we're going to do now is we're not going to call this y1, we're going to call it f of x. We're going to use function notation. And again, it's kind of important to really understand the second way of doing things here. And then over here, that means instead of calling this y2, we're going to call f of x plus h. So we're going to think of this as f of x plus h. Now, back in the olden days, we learned something called slope, right? Slope. Slope. Slope is y2 minus y1 over x2 minus x1. And that's not earth-shattering. We know about slope, right? Right? But this is like really important, okay? This is super important, okay? It's not hard, we all know slope. Now, but here's the thing. We're going to write it like this. Again, we're going to use the notation y2 minus y1 over x2 minus x1. Now, what you probably notice here is the x's are going to cancel, and this is how we're going to write slope from now on in this class. Okay. This is how you write slope in algebra. This is how you're going to write slope in calculus. And that's the slope of this line, right? That's the slope of this line. What's calculus? This is kind of cool, okay? Kind of cool, okay? Because it's not that hard, okay? It's not that hard. It's really this simple. I mean, philosophically, but the work is really hard, okay? I'm not going to say it's easy. What Newton said was, what if we let this point get infinitely close to that point? What's that called? That's called a limit. So what? Now here, okay, this is it. This is it. Wait. Slope. This is the slope. Okay. In green, that's the slope. Okay. Now, what would the derivative be? Is the limit as x2 approaches x1 of y2 minus y1 over x2 minus x1. That's the, hey, wait a minute. If I take that away, I got slope. Wait, watch this. Slope, derivative. Slope, derivative. So again, and here it is. Finally we're done. This is the way we're going to write it as h goes to 0. And this is probably why you might hopefully recognize from the homework. F of x plus h minus f of x all over h. This is the derivative. The most important thing in this class. Seems so simple to be super duper important, but it's ungodly important, okay? It's ungodly important. Why? Because what happens then, and this is what you want to kind of get the point, and now you can start seeing maybe where Newton was going with this. If we let that point get infinitely close to this point, notice something kind of weird. This is the slope. You need 2 points. This is the derivative. Notice what we're doing. We're finding the slope at 1 point, or what we call the tangent slope. We're finding the slope at normally you need 2 points to find a slope. Now we're finding the slope at 1 point. Well, it's not really 1 point. We're putting the 2 points so close together that they're really 1 point in a kind of certain way of thinking about it. Okay, let's think about this. Now, that's it right here, guys. This is your life for the next 20 weeks, right? Until Christmas time, right? This thing called the derivative is every question we do from here on out for this semester will have some kind of derivative in it, and that's just the way it is, okay? This is super important. Okay. Now, let's talk about, let's try to give an example to this. Okay. So, this is called the derivative. No, guys, watch. Derivative, slope. Derivative, slope. Derivative, slope. So they're really similar, But what we're doing is we're not taking 2 points, we're gonna move that other point on top of the first point by taking something called a limit that Newton came up with. So, hold on, I'm gonna move this thing over here. So, let's look at let's try to do like, I'm gonna pretend I'm Newton thinking about this, which I have no idea what he was really thinking at the time, but let's just pretend I do. So Newton's gonna drop a rock off a cliff, okay? So when he drops the rock off a cliff, he notices that after 1 second, the rock fell 4.9 feet, meters. So what Newton notices, crap, 4.9. And if you're in physics, you may have come across this already. If you're not in physics, do not worry about it when I explain it. Dun, dun, dun. So let's just pretend that now instead of using f of x, I want to use an equation, okay? Kind of illustrate this idea, okay? So what we're going to have here is the derivative versus the slope. But instead of thinking of it as instantaneous rate of change versus average rate of change, we're thinking of instantaneous velocity over average velocity. Because velocity is the rate of change of the displacement, so it's really the same thing, okay? So we do some experimentation, and after 1 second, 4.9 meters, 2 seconds, 19.6, 3 seconds, 44.1, 4 seconds, 78.4, and 5 seconds, t seconds, we realize that it's 4.9 t squared. That's how you're getting these numbers. So here's the difference here. What would the average rate of change be between 3 and 4 seconds? The average rate of change is slope. So the average velocity, or what we call the average rate of change, average rate of change would be from 3 to 4 seconds. What we're going to do is from 3 to 4 seconds, just because that's where I drew the line, the secant line. The slope, which would be the velocity. Remember, the velocity would be the slope of that line. The average velocity, remember why? Because it's distance divided by time, right? So v is the distance at 4 seconds minus the distance at 3 seconds over 4 seconds minus 3 seconds. So it's that's how we would figure that out, okay? And so at 4 seconds, I'm 78.4 minus 3 seconds, 44.1, all divided by 1 second. So what I could do is I could figure out what the average speed was. I went over 1 second, up whatever that subtraction is, to get the average rate of change, the average speed over that 1 second. But that's not what Newton wanted to know. Newton wants this to come in here. And he wants to find what was the actual speed that the object was going, which would be the slope of the line there. That's what he wants to know. So Newton's saying, wait a minute, no. I want the limit as h approaches 0 of 16 no, guys, why am I using 16? Oh, you know what I think I'll do now? Wait. Let me stop here. Okay? We'll save this for the next video, okay? I'm going to start here, okay? So the derivative is right here. Now, why did Newton want to know it? Because Newton didn't want to know what the average speed was from 3 seconds to 4 seconds. He wants to know how fast I'm going precisely at 3 seconds. Okay, so let's stop here, and then what we'll do is I'll continue this question when we come back for the next video.